Recording. There it is.
28th of May.
We are recording. Yes, is it the 28th of May?
It is. 2015.
28th of May, 2015.
Approximate time is
Algebra 2.
something.
WSSB. Okay, we are on page 705. Some applications of trig. What braille page is it? B? Okay.
It'd be.
Some applications of trig use an angle of elevation or depression. In the figure, the angle formed by the line of sight from the observer. So they've got an observer on the ground looking up at an airplane, and that's called the line of sight. And a line parallel to the ground is called the angle of elevation. So if you imagine, if you would, you were standing and you looked straight forward, the line going straight forward is just this parallel line to the ground, and then you tip your eyes up and you look up at an airplane. Now you've created an angle of elevation because you're looking up compared to that parallel line. So it shows you that. So go to the bottom left corner vertex, and there should be a little dot there that's representing the person.
Oh.
Okay?
Oh, that's the person.
If you go horizontally immediately to the right, that's
He's looking at the airplane.
your base side, right, of a right. Then you go at an angle from that dot up till, imagine if you're at like 7 o'clock and you go to 1 o'clock from that vertex. That's the angle of elevation, that angle in between the line that's parallel to the ground and the angle, and then the line that's going at the angle up the airplane. Okay?
That makes a triangle.
The angle formed by the line of sight from the plane and the line parallel to the ground is called the angle of depression. So if you were up on the plane
and
you were looking down at the person from the plane, you have a line that's parallel from the plane to the ground, and then the line down. That's the angle of depression. Okay? Does that make sense?
Yes.
Okay. Now, could you create right triangles out of all of that?
Yeah.
Sure.
You could make a square.
You can make a rectangle. And then you would create a right angle going from your parallel line vertically up, right?
Well, you wouldn't. You would make a right angle, but you would still know where the vertical angle.
Yes.
Or the elevation, angle of elevation, and all that.
This is really important, and tap into your geometry brains. The angle of elevation and the angle of depression are congruent. Why are they congruent?
Because it's not corresponding.
Your rectangle.
Well, no.
I forgot what it was called.
In geometry land, you have two parallel lines, and that angle, that line of sight, is your transversal.
It's not correct.
You have two parallel lines. That's your transversal. What kind of angles are they creating when they create the angle of depression and angle of elevation? Alternate interior angles, right? Alternate interior angles are always, parallel lines are always congruent, aren't they? So your angle of elevation is going to be the same as your angle of depression. So if you find one, you know the other, correct?
Yeah.
Okay. All right, so let's go use this in example 7 for skiing.
Well, how high is this airplane?
It tells you a little tidbit of skiing in a sidebar here. It says skiing. The average annual snowfall in Snowbird, Utah is 500 inches. The longest designated run there is Chip's Run at 2.5 miles.
Sure.
Is this true also? The angle of elevation and depression can't be really greater than 90 degrees from what we can see.
Well, the angle of elevation or depression has to be, that's an acute angle, because you have a 90-degree angle going straight.
Yeah, it can't be greater, or
right.
it can't be. It has to be less than.
Left over or less than 90, because they have to add up together to be 90, don't they? In a right triangle.
Well, you can have it at 89 degrees.
You'll never have an angle of depression or elevation at 90.
Yeah, but could you still have it at 89 degrees?
Sure.
Ooh, that's very steep.
That is. All right. The aerial run in Snowbird, Utah has an angle of elevation of 20.2 degrees. Its vertical drop is 2,900 feet. Estimate the length of this run. So notice they give you a graphic to look at, and it's nice and tidy. It's a right triangle, isn't it? They show you that the left vertex is 20.2 degrees, so that's going to be your theta, isn't it?
Yeah.
The right angle is at the bottom right vertex. They're showing straight up from that. That's your
We want the sine of 20.2.
drop. Your vertical drop is 2,900 feet.
God, that'd be a horrible one.
And they're asking for the length of the run. So if you went from the top at a slope down to the bottom left, top right to bottom left, they're labeling that with a italicized L. That's your hypotenuse, isn't it?
The hypotenuse.
So they want to know the hypotenuse, and they give you one of the legs, and they give you a theta angle. So notice that if you think about SOHCAHTOA,
Is it 1,901?
they're giving you opposite over hypotenuse, aren't they?
Oh.
So they're giving you O, which is sine, isn't it? So the sine of 20.2 degrees.
Know how to do this on the calculator.
Oh, do they? All right.
Yeah.
Has to equal 2,900 over L. Okay, you need your calculators.
First.
All right.
Solve for L first.
Got to solve for L. Right? So the sine of 20.2 degrees equals 2,900. If we solve for L, L would equal 2,900 divided by the sine of 20.2, right?
Did you say 20.2?
20.2 degrees, yep.
Theta.
That's your theta.
Sine.
Yeah.
Point two. Oh yeah. Sorry. One of the brain is 0.2 divided by 2,900.
No, other way
Wrong way.
around.
You
2,900
gotta be careful
divided by
about
your
it.
sine.
Sine of 20.2.
L is in the denominator.
Good job.
Woo! That's the first one you get it. And I kept messing up the sign.
So approximately 400 feet.
Yes. If you...
Oh, 8,000.
Yeah, that's what I got.
I got that too. All right.
Oh,
wait,
what's
you gotta
number?
do, you gotta do this
You did it.
first.
I did it. What is the number?
It's in your book.
On the answers?
8,000.
Example. Check the book and see if you agree. Tells you how big L is.
1,000.
Yeah.
No, you did it.
See, you did
You
it.
divided it. You did it right, baby. You got to divide 2,900 by 20.2. Sine of 20.2.
I have 8,000.
That wasn't so bad.
Piece of cake. Isn't that cool? I love trig.
8,398.53786.
Yep.
Nice.
Wow. That's so awkward. I think it's simpler. At least it's just me. I cross multiply so much it doesn't. I don't know why I cross multiply.
You cross multiply, yeah. 20.2 times L equals 2,900. So I'm going to divide by 20.2, right?
Sine.
JJ strikes
Cross
again.
multiply, divide by odd man out.
Not so bad.
All right, here we go. Let's go work some more of these.
There's a number of interesting open-ended.
JJ.
Or you can start at 3 and go through 14.
I think we should just go have some fun with.
What? Why would they end the volume with the section? That's stupid.
We need a new book after this. Should we get a new book?
End of
Yeah, the
volume
problems,
7,
that's
end of
weird.
volume 46.
That's stupid.
They don't
Who
have
ends
your-
the book before the problem?
I don't know.
End the book. That's
Oh,
the stupidest thing I've ever heard.
That
Like,
is dumb
they
because
could
how do you
just
go
add
look
like
at your
3 more
examples?
pages of problems.
All
No.
right, let me go get 47.
I don't want to.
Spanish
to read the
teachers,
book. I don't
my
wanna-
Spanish teacher started raving about the Braille book this year. He's like, they stop the book after your vocabulary list, before the examples you use. to
Yeah,
fix
that's
your
so
vocab.
dumb.
He's like, I hate your Braille. I hate
You
it.
know, maybe we actually need a blind person working to make the books.
Seriously.
Is that a thought that we should look into?
Yes.
Who wants to go work as a brailleist for giant books?
Are you kidding me?
Not me.
Nope.
I don't have transcriber patience.
I don't have enough patience. I don't have
I'll
enough.
do it. I love
Okay.
I love stuff like
Do
that.
it.
It takes forever.
Oh,
So,
it's smaller.
song.
What?
Which job did you do against to?
Oh yeah, you gotta find your job. What do you do?
I went.
I looked into some office work at a chemical dependency facility.
Hey, that
Ooh.
sounds like up your alley.
It does.
As long as you don't.
Either that or I do job shadowing there, or I can work in Washington talking about umbrella library.
That's so boring, but you can do whatever you want while you rewind tape.
Let's look at number 13.
See, that's why I like it.
It'd be great if you guys could work at the client assistance
We're gonna
bureau.
use
That
it.
was pretty fun.
716.
Page 706, number 13.
Oh, 06?
Aviation. So
Oh.
this kid almost.
Hey, 0715.
This is the problem for Casey.
Well, I mean, let's see. 706 has a guide practice.
There's a bunch of open-ended questions.
No, they're not too bad.
Which- Are we working on number 4?
Draw your own triangle.
Yeah. I want a triangle of 64 degrees.
What are you drawing?
You have one.
She's drawing something. I gotta figure out where is it.
Triangle if you had a 179 degree angle and a 0.5 degree angle for the other two.
Here's number 13. No?
Miss JJ, what are you looking at?
I'm looking at number 13 and there's a drawing for it.
Aviation.
This is aviation.
A jet will average a
I think it's this one right here.
I see
angle
14.
of descent.
And I
What
see
is
13. I see 9, 10, 11, 12, 13.
Out.
Yeah, it's this one. 6.
Three.
Am I?
When landing, a jet will average a 3-degree angle of descent. What is the altitude x to the nearest foot of a jet on a final descent that passes over an airport beacon 6 miles from the start of the runway? So notice they drew a right triangle.
Uh-huh.
Your left bottom vertex is the runway. Then it has 6 miles to
Yeah.
goal on the right that then goes up to the airplane. That's x. We don't know where that is. And then its angle of descent is 3 degrees. So what do you know about the angle of descent in relation?
We could do a tangent of 3 degrees.
We could, because tangent equals TOA, doesn't it? Opposite over adjacent. So x is your opposite, and what is your adjacent? 6. So you're going to have tangent of 3 degrees equals x over 6.
So 6
So
divided by the
x
tangent
no.
of 3.
How do you get x by itself? Is if it's x over
Oh, multiply.
6,
Multiply.
right?
Of course.
So multiply. So tangent of 3 degrees multiplied by 6
Tangent
equals x.
3. Tangent 3. 0.05248 times 6. 0.314447.
Would it be 114.48682?
What?
No, it's 0.31447.
I don't know.
Oh, here's the trick. 6 miles, but they want to know in feet. So you're going to get it in miles. Now you got to get that in feet. How many feet per mile?
5,280 feet.
Right.
What? How do you just know that?
So you got to multiply by 5,280.
Read.
So times this 0.3144 by 5,280.
1,660.
There you go.
0.278448.
There you go.
Okay, Jerry.
That was the trick on that. If you answered .03 whatever it was, .3 something something, that's in miles, isn't it? And they asked for in feet, so you got to remember to convert to feet, which is times
0.3 miles in the sky? That is
0.3 miles in the sky. It's not very high.
I know.
But if you've ever been to an airport, have you ever been to an airport?
Yeah.
Have you ever
Yes.
hung
I flew
out,
back and forth
like,
for a while.
listened to or watched the airplanes come in?
Arizona's the best.
They are not very high up in the air when they come in, are they?
Have you ever
They
seen
land.
their angle of descent is 3 degrees.
And this is a 3-degree angle. Little.
They can't just drop out of the sky. They have to have some time to be able to descend, don't they?
That's what I need to create. I need to just create a drop landing.
That would not be effective, probably.
That would revolutionize
It would
transportation.
be effective at population control.
Yes, you're right.
God.
And it's recorded.
That's so mean.
Dark.
That's so mean.
Oh man.
Fine.
Well, not as.
It's okay. We know our recorders are awesome.
All right. Let's move all the way over. Find number 41 on page 707.
What? Wow.
Why are you making us go so far? Because we're just gonna go back again.
Maybe.
41 is on E707.
Travel.
E707. Travel.
Yeah.
Oh, dang.
Travel in sightseeing boats near the base of the horse. What is this?
Horseshoe Falls.
Horseshoe Fall at Niagara.
Niagara Falls.
Niagara Falls. Passenger estimate the angle of elevation to the top of the falls to be 30 degrees. Ooh, maybe we'll get a 30, 60, 90.
Ooh.
If the
thinking.
Porsche Falls are 163 feet high, what is the distance from the boat to the base of the fall? So we're just finding the bottom of the triangle.
Survey.
And we know the height.
30.
So that means we need the tangent of 30 degrees.
What is it telling you? The Horseshoe Falls is 173 feet.
Tall.
They told you the angle of elevation is what? 30 degrees.
Oh, wait, it's an angle of elevation.
Jeez.
They want you to figure out the
Oh,
distance from the boat to the. Okay, gotcha.
Yeah, he's right.
Okay.
I guess it works.
Picture. Do you like my picture?
30.
Here's the waterfall.
Oh, wow, it's pretty water.
There's the boat.
Oh, wow, look at that. It's like a
Angle
pirate
of
boat.
elevation. It's 173 feet tall, and we're looking for X. Did I draw a pretty
Oh.
drawing?
Yes, you did. The triangle's a little bit slippery.
Oh,
Okay, but
perfect.
it's all good.
All right, so you're going to use TOA. Why are you going to use tangent?
Because I said so.
Because it's the opposite over adjacent.
All right, so what is the opposite?
X.
No, it's the height of the thing.
And
173.
opposite is the 173. The adjacent is the X. You have
173
tangent of
over
30
X.
equals
173 over
173 over X.
X. So that would mean we have to multiply tangent of 30 by 173
No.
over X.
You've got tangent of 30 equals 173 over X, or divided by X. That actually means that you have the tangent of 30 times X equals 173, which means X is going to equal 173 divided by the tangent of 30, right? Be very careful.
over X.
Be very careful with your pre-algebra skills, right? Don't always assume that it's division. Think about where your X is.
Is could it be 299 feet?
Or
Or is that wrong?
Yep, round to the nearest, so 300. Yep, about 300 feet. Tangent of, or 173 divided by the tangent of 30.
Yeah, see, when I'm too lazy, when it's like the number over X, I just do 1 over the tangent and multiply.
Yep, that's cool.
Because it's easier, I think. Because X is X, so it doesn't do anything.
The snickerdoodles in the ELS room, I guess, are for the staff.
Snickerdoodles in the DLS
I made
room,
those.
or for the staff people.
Snickerdoodles?
I tried to get one
I love
earlier and
those.
I was denied.
Who named a snickerdoodle?
Yeah.
I was
Maybe they doodle on a Snicker before they ship it.
A Snicker and a noodle.
They snickered and they doodled.
They snickered at it and then they
Doodle.
doodled it. And then
I think it's the other way around.
Why?
They doodled. Wait, they doodled a
It's
Snicker.
funny when you do it.
A doodle?
They doodled a Snicker.
They must have been divas.
Why are snickerdoodles called snickerdoodles?
Oh no, do you realize we're recording?
Yay!
Why are
Why not? It makes it fun.
snickerdoodles called?
that might be too much phrasing. You might just need
Why is
just the word snickerdoodle name and why.
Staff people.
The snickerdoodle cookie is most commonly thought to have originated in Germany, and its name is derived from the German word Schneckennudeln, which means snail dumpling.
What?
Schneckennudeln is a German cookie that is crunchy and sprinkled with cinnamon.
Cinnamon.
Another popular theory surrounding the origin of the snickerdoodle cookie is that it is named after Snickerdoodle the superhero, a hero who appeared in a variety of storybooks. The mystery as to whether the character was named after the cookie or the cookie was named after the character has yet to be solved. Snickerdoodle cookies are made with eggs, butter, sugar, cream, tartar, and flour. Prior to baking, the snickerdoodle dough is rolled in cinnamon sugar. Snickerdoodles are typically baked until crispy, but they can be baked at lower heat for a softer cookie. Snickerdoodles are often commonly referred to as sugar cookies, but there are slight differences between the two. Snickerdoodles are sprinkled with cinnamon and are thick with a crunchy texture, while sugar cookies are sprinkled with white sugar and are typically thin and soft in texture. The cinnamon in the snickerdoodle is balanced with cream of tartar, resulting in a flavor that is both sweet and spicy.
Spicy.
Schneckennudeln. Snail dumpling. So the snickerdoodle is a snail dumpling.
Ah, no.
I don't know if I want to eat your
I
snail,
don't know
Carly.
if I want a snail dumpling.
No.
Wait, who has snickerdoodles?
That sounds like it might be a snail poop.
It's not like it's even big enough for you to notice.
What do we learn in Algebra 2 at WSSB?
Snail dump.
Schneckennudeln.
Schneckennudeln.
Now it's for Clint Eastwood to say that.
We're practicing.
How would Clint Eastwood say that?
Well, that's cool. We figured out the height of the waterfall.
Yeah, I told that.
Ooh, Miss JJ, on a sunny day,
Yes?
you could take everybody else outside,
Get back to
and
math.
based on their shadow and their height, you could, or based on,
You're right.
you could like do this real experiment.
I know you can. You can figure out elevations of different things based
You can
upon
find the
the
angle of
height.
elevation by all three sides.
Yep, that's right.
Have a tape measure on the top of your
We
head.
might have to do that next week. Okay,
What time?
it is 11:15.
I have to
Okay.
leave early today, JJ.
We figured out. Let's go to number 42. Surveying.
Surveying.
42.
Survey.
Logical question.
Understands 100 feet.
There's a sidebar called career choices. Do you guys know what surveyors are?
Yeah, there are people.
They look at buildings and they leave little weird arrows with a bolt in the middle of the ground pointing some direction.
Sometimes they do. Surveyors. Now, these are land surveyors. Land surveyors manage survey parties that measure distances, directions, and angles between points, lines, and contours in the Earth's surface. So, in order to build things out in the middle of the Earth and the world, we just don't walk up and go, oh, I think I'll put a road here. We survey the land. We figure out all the math around the land with the points and the lines and the contours so that civil engineers can design and plan how to build that road or build that sidewalk or
Otherwise, the road may sink.
put the
something.
building in a certain spot. The architect or the builder for a home would want to know, well, where are we going to put the house? Where is the property line?
Where do they drill your own
And
well?
drill your own well. There's all sorts of things. So surveyors use special equipment and math to
GPS.
figure out where that is, and they do things like put little nails and ribbons in the ground to mark certain points, tie ribbons around trees to mark certain lines, and
I always
it's for
remember
them
those
to
ribbons.
figure out where it is. And they use, nowadays with technology, they're able to use lasers to do this,
Later.
which is really cool.
Laser pointer, yeah.
These are pointers and stuff,
Right.
yeah. All right, so here we go. Number 42. A surveyor stands 100 feet from a building.
So just draw a giant horizontal line.
I'm going to draw a little building. Look at.
Oh, cool. That's easy. A skyscraper, or are you just gonna draw like a house?
Draw a little. You want a
A
skyscraper
3-story building. That's cool.
building? Okay, is that good enough for you?
Sure.
All right. And they are 100 feet from the building. So I'm going to draw a little stick man. 100 feet from the building. 100 feet. Okay. And sights the top of the building
Angle of
at a
elevation.
55-degree angle of elevation. Find the height of the building.
Ooh, adjacent, opposite over adjacent. Man, they keep loving this.
Tangent
They keep
again?
doing it.
Yeah.
This is boring.
This is boring.
Doing
Sine or
tangents.
cosine?
Tangents is opposite. So we don't know the opposite, but we do know the adjacent. So it's, what is it? Tangent 55 equals what?
X over 300.
100.
100.
They're 100 feet from the building.
120.
So what?
That would mean
100
over
X.
What?
Opposite over adjacent.
The opposite is the building.
Oh yeah.
They're 100 feet from
Oh,
the
yeah.
building.
I was
Okay.
thinking of the other way.
Okay. Shoot.
The
All
building's
right.
not 100
X
feet
over
tall.
100.
Yeah.
Got it.
Then we
Okay.
multiply
So you multiply what, Carly?
the tangent by 100.
Yes.
Yeah, you got it.
That's right.
'Cause it's in the
Tangent of
numerator.
55 degrees times 100. What do you get?
Ooh.
That's not. Does the negative number make sense?
No. It's 14 point. It's 142.8481.
So in parentheses might be good, or hit enter first and then multiply by.
The tangent of what? I heard tangent of 100.
142.
There you go. Now do it.
Yeah.
Yay, got it.
There we go. 143 feet.
How about that? Yeah.
Thereabouts. Ta-da!
Tall building. Good thing you made a skyscraper.
It's like the World
Can I
Trade
leave at
Center.
11:30, JJ? Then you stop by the nurse.
You may. All right. Let's see. Let's go do a standardized practice question. Page 708, number 50.
What a man.
Number 50. Ooh. Divisible by 5.
Looks like
Or
it has a
10.
drawing. No, no.
There is a drawing of a tailgate of a moving
43, 44,
Hey, my dad hates
46, 47, 48,
It's
Seven
B song.
and
B
eight.
song.
50. Yeah, B70A. 50. Grid. Grid?
Yes.
Grid A.
Because on standardized tests, they have you write what you're going to do, right? They want to see your work.
Good.
And this will be the.
All right, so the tailgate of a moving truck is 2 feet above the ground. The incline of the ramp used for loading the truck is 15 degrees. So find the length of the ramp to the nearest tenth of a foot.
Oh gosh.
So if you're on the ground and you're going straight up to the tailgate,
There's 2 feet.
that's 2 feet. And then you're going to have to go out from the tailgate.
Finally, we don't have to use tangent.
We're not using tangent. What do we have there?
I think it has to be 15 is one of the legs, and it's the adjacent leg. So
15 degrees
The first one.
Okay.
The first one.
is the angle.
Maybe you pass a sign in the truck.
could it be the sine?
Yes.
Opposite over.
Opposite of hypotenuse.
Yeah, it's
I'm trying
sine.
to find the length of the ramp.
Because you're trying to find the length of the ramp, the hypotenuse. And you have the opposite of your theta.
2
Hold on.
over x.
So sine of 15 degrees equals what? 2 over x?
2 over.
So what does that mean you're going to do?
Divide.
Divide. 2 divided by sine of 15 degrees.
2.
To round to the nearest tenth of a foot.
Trig.
These are feet in tenths.
7.7.
7.7. Yep.
Yep.
6.1.
Always.
Why do you guys divide? It's so difficult to divide.
Not that hard to just do it.
I just cross multiply. I just do 1 over everything. I do 1
Stop
over.
being a schnecken noodling.
Oh man.
Wants to know.
I already, you can do it a number of ways. Whatever is most comfortable for you.
I know. It's just dividing sounds so hard.
What they would want to see on this is that you wrote out that you needed sine equals opposite over hypotenuse, that you wrote out sine 15 degrees equals 2 over x, and then you just do the work in
Solve
your
it your own
calculator
way.
and write down, and you probably get full credit for that. They just want to see that you recognize sine over sine. All right. Let's see. Let's take a look at where else. What else could we do? What else could we do, Miss Steinbach?
Ooh, let's do like number 20. I don't know.
Number 20?
I haven't been looking. I'm just saying numbers. Let me look.
You want to do number 46, geology?
Sure.
6 on page 708.
You don't deny problems, because then you're gonna make your teacher cry.
Geology. This is why I like trig, because it's so real world. Like, all this stuff, you go, oh, this is where I use it.
Critical thinking. Explain why the sign.
Not that one, 46.
Okay.
It's on the page break, but it's on B707. Oh, G707.
Alright, guys. Geology.
What?
G for geology.
It is G, huh? G. It's actually. Never mind.
So we're drawing an angle of elevation, so it's
Oh,
going to be
Wait.
up.
Am I reading this?
Yeah, go
Sure.
ahead.
Okay.
I kind of want to
Geology. A geologist measured a 40-degree angle of elevation to the top of a mountain. 40-degree angle of elevation to the top of a mountain. After moving 0.5 kilometers farther away, the angle L, is that L? Oh, the angle of elevation was 34 degrees. How high is the top of the mountain?
Hint.
Open hint. Right. A system of equations in two variables. Close parent.
System of equations.
You know,
How long ago was that?
It was like back in November or
It
October.
well,
was a
Pretty
long
long time.
time ago.
It was
Back in
before-
2014.
before Matrix.
Well, what could we write here? They have a picture for you, which is kind of nice. They have they have the mountain, and they don't show the mountain in your braille, but it shows the triangle that it creates to the height of the mountain, h. You have one triangle that's got an x degree base with a 40-degree acute angle in the lower left. Then they have another triangle that has same height, CPCTC. And then a base that has the x and another 5 kilometers, and then its angle is 34 degrees. How would you?
Well, we could figure out the first triangle adjacent over. Well, I mean, depending on if you want to figure out, it's probably better if we figure out the hypotenuse. Actually, so maybe we should just do adjacent over hypotenuse. So we could do cosine of. I lost your picture. Can I have your picture? I lost your picture.
I'm sorry.
A little bit to the right. Adjacent of 34, or cosine of 34 degrees.
She said, how high are those planes are going on this?
That's series 4.
Is it necessary to find the hypotenuse? I mean, that's one way to go.
Well, because then you figure out the hypotenuse of the entire giant triangle.
Okay.
Because it matches. Doesn't it?
JJ.
And then if you wanted to figure out this entire thing, then you can take a cosine of the entire thing and figure out the base, and then you could just do the Pythagorean theorem. Wouldn't that work?
That would.
So you figure out the little triangle on the right or left, the one with the 5 kilometer base, Or
That's
0.5.
not, but no, that's not a 5 kilometer base for the little triangle because that little triangle on the left is not a right triangle.
Is it not?
No.
No right
Oh,
triangle.
you're right. It is not a triangle.
It's a big, huge triangle that's a right triangle with a 34-degree angle, and then it's a smaller triangle inside of that, a smaller right triangle with a 40-degree angle. So you have two right triangles, the big, huge one.
Ugh, I don't want to make a systematic table then.
All right, I think I would do opposite over adjacent.
Tell again.
So you're going to have tangent of 34 degrees equals h over what?
Depending on what
H over point
0.5 plus x, right?
because we wouldn't know what it was. Yeah.
You got to add the 0.5 to x. Then you have tangent of 40 degrees equals h over x, don't you?
I don't know.
Can we figure out the tangent of 40 first?
Well, you don't know anything right now. We just know it's H.
We've all forgotten.
It's a system.
Gotta use your tools.
That's why I did that just because we did.
Elimination or substitution.
That's kind of what
Okay.
that's kind of what I wanted
I
to
like
do.
that.
Why don't we can do you want to do substitution or elimination? I would advise that you figure out what is the value of the tangent of 34, just so you're not looking at that anymore. What is the value of the tangent of 40? So somebody tell me tangent of 34.
Read more. It's not clear. Just read that. Read more. 0.6745 Just read.
0.6745.
All right, I'm going to go 0.6745 equals h over 0.5 plus x. Then what is tangent of 40?
0.5. Clear. Just read.
8391.
0.8391
Yeah.
equals h over x.
Now those nasty little things are.
All right. Now, what do you want to solve for to substitute back in?
X? No. H.
You want to solve for h? All right. On which one?
Let's start with the big one.
Big one. Tangent
Clear.
of
Just read.
So you want to do tangent of 40 equals
30.
h over x. So how would you solve for h? Multiply by x on both sides?
divide.
So 0.8391x equals h. Is that what you're telling me to do? Yeah?
You get h all by itself when you have decimal equals h over x.
Oh, divide.
Not divide. H over x. How would you multiply by x? Okay. So h equals 0.8391x. So do you want? So you're saying substitute that in for h on the first one. So 0.645 equals 0.8391x all over 0.5 plus x. Is that what you're telling me to do?
Wow.
Yeah?
It's a nasty problem.
So
It's
then
a big
how
one.
are you going to get rid of that 0.5 plus x in the
Minus
denominator?
0.5.
No. You got 0.8391x all over 0.5 plus x.
Multiply by
Multiply, yeah,
the-
multiply
It would
both
help if you were writing
sides.
this down because I think you're getting lost. I know it's hard to keep track of all this in one head.
and then you can subtract x.
So you got to
No, you can't.
distribute. You have to distribute the 0.6745 to the 0.5 and to the x.
That's a lot.
What is 0.6745 times 0.5?
It's just divide that by 2. It's a 0.3 something.
Yep. 3 something. Can you do that for me? 0.6745 divided by 2.
0.33715.
3725.
All right. And that's going to be plus
Plus
0.6745x, right? Equals 0.8391x.
And then you can subtract.
Subtract 0.6745x from both sides, right?
Holy
So
crap,
what is
I'm lost.
8391? You got to write this down.
Yeah, that's
people.
why
You
all of
can't-
you are lost, because you
You're
haven't been
not
writing it down.
taking notes. You're trying to follow it, and all the decimals are messy. So you have 0.3372 equals, what's 0.8391 minus 0.6745?
Did you say 6745?
Uh-huh.
Is it really 6745?
Yeah.
Mm-hmm.
Oh,
It's 0.16.
1646.
So you have 0.3372 equals 0.1646x. What do
Now
you got
what
to
do
do
we
now?
Divide by.
Divide by.
What is 3372 divided by 0.3372 divided by 0.1646?
All right, Tanner, you should go see Mr. Grandstaff.
2.048.
What's the homework?
I'll give you guys a break since you have a concert in awards tonight.
So the question is, what did this? I mean, this achieved us
This is gonna get you x,
of x.
Height. I mean,
not the height, just the x. So it gets you the
bottom
base,
thing.
the adjacent.
Which is very helpful, but I don't want to take that's the adjacent
So it gets you the
observer.
adjacent of your.
I don't want to take the tangent of 2.04863. Can I just take the tangent of 2?
No, they're
No.
completely different numbers. That's fine though.
But what is 0.3672 divided by 0.1646? Somebody tell me.
That was it, wasn't it? 2.048.
2.048. Okay. So now you can do you can plug that in. You can substitute that in, can't you? Tangent of 40
Yeah.
degrees equals h over 2.048, right?
Mm-hmm.
So then you're going to divide or times tangent of 40 times 2.048.
Yep.
And you'll get the height of your mountain. That's the way to do it.
What if we just did the tangent of 40, whatever that 40-degree tangent?
Yeah.
Wouldn't that work too? Because it's the same
Tangent
rest of
of
the triangle height.
40, yeah, which is the point, what was it, 0.8391 times 2.048.
Remember, we're in kilometers.
1.7 kilometers.
Pretty big mountain.
That is?
Bananas.
I guess, yeah, kilometer is
0.62 of a mile.
1,000. Yeah. That's a very far mountain, actually. I don't want to be up there.
So if you did
Kind of
1.7 times 0.62, oops,
Oh, are you trying to figure out how many miles?
62. It's a little over a mile
Tall mountain.
times 5,280.
How many feet?
5,500 feet about. It's not that tall. It's half the size of Mount Hood.
I bet people could stand up there and be fine. Somewhat.
The oxygen starts to get a little less at that.
Yeah. I don't like hiking or anything because when you go down, you feel like if you fell, you like continue to roll until you hit the base. I don't know.
Where are you going hiking?
Oh, we're just hiking up giant hills and stuff, and when you try to come back down, it's awful, I think.
Well, at least you're
Down,
not
you need
hiking
to
Mount
be a little
Everest.
more careful. Yeah.
I like to go up if it's gonna go anywhere,
And-
because then it's easier to go up. You just kind of sit there.
Remember Hannah had that dream. Wait, how are they down? Oh, they actually have to go down ourselves and not take a lift down? That would have been quite efficient. Well, that's it for today, folks.
You want to work out another problem or what?
Oh, that one.
I think it's.
Won't hurt you. You
Yeah,
got 4
at least
minutes.
we only got 4 more minutes left.
Ah, we could probably do a small one.
I was just trying to refresh everyone's memory.
All right.
That's why I said that.
I'm going to hit the stop record button.